now I'd like to quickly go through the Apex installation guide. This is version 13. There are previous versions around if you're doing maintenance, and they are available on the website or from our technical department. This is the current version, and it will be the version going forward with very minor changes. So this is available at the website. It's under kamedownload.net, documents, tech docs, Entratech, Apex installation guide.pdf. Okay, so the first pages take you through some legal information, which I don't really need to read out to you. It's there if you need to see that information. The very important part of this document is the cabling requirements. So I will just scroll down to the bottom of this page and make you aware of this part here. So it says here, do not use CCA, CCS or CCAM cable. What there are a lot of cheap copy type cables around. The system is designed to work on twisted pair cable, which is a telecoms cable, either CW1308, Cat5, Cat6, Cat7. It isn't designed to work on twisted alarm type cable, and it has to be pure copper solid core. So what these cables are is they're a copper clad, so they're actually copper clad an aluminium cable, and a copper clad a steel cable, or in this case a magnesium cable. What it does, the cable then doesn't have the ability to carry the current, which makes a lot of strange, weird and wonderful issues with the system. It isn't a inherent problem just to the Entratech system. It would be the same across all industries. So just double check when you get your cable from your wholesalers that it is a pure copper cable, not copper clad. The same applies when you're using the RG59 coax. Whilst there will be many out there that have got a copper clad braid, it's very important that the center core is copper. Okay, apologies for making that point 3 or 4 times, but it really is important to the system. You could spend a long time searching out for faults that were caused by that issue. Okay, so just there it tells you exactly what the system should be. So UTP is unshielded twisted pair. It therefore tells you the construction, transmission, performance of that cable, and as I mentioned there, it's CW1308, Cat5 or Cat6, and it tells you there the diameter, the minimum diameter it needs to be. All Entratech documentation will use similar lettering to explain the cable required. So any drawings you see, it will indicate cable A will mean these colours. These cables, I apologise. So therefore it takes you through exactly what they are there. So a controller to an ED3, ED4, EV or EV plus, so that's your handsets, and it tells you there exactly the cabling you require. Again, it tells you there for a Vogue unit. One I'd like to draw your attention to is a controller with a power supply to a controller with a power supply. So for our system, it's very important that the 0 volt output of the power supplies are linked to one central earth point. So I'm just going to jump through a few pages to page number 9 and explain this a little bit better. So here we go. On page 9, it shows you here how the system would actually wire up. The way the system works is that we build equipment, we don't build for the site. What we do is everything on this chassis plate is isolated from the mains earth. So when you bring your mains earth in, you bring your mains supply into the breaker there, and you connect the earth to the bolt that's pre-made for you. What you then do is on the output side, on the low voltage 12 volt DC side, you have a pre-made link wire that links the mains earthed chassis point to the DC voltage 0 volts. Now it's very important that that is only earthed at one point. So when you go to the next cabinet up or the next building along, you need to take that pre-made link out and run a 6mm black cable between the 0 volt of the first power supply and then the 0 volt of any more power supplies. What that means is that all of your equipment is electronically earthed. It's mains safety earthed. The chassis plate is earthed. However, the 0 volt reference of the system is all at one point. Usually that would be the ground floor, but it could be any point as long as it is only the one point. So you do need to remember just to remove that pre-made link on all power supplies. Okay, I'll just jump back up to the cables now and we'll quickly go over those. So the reason we recommend a 6mm earth is that it actually has to be a 2.5 times your highest conductor. 6mm is a standard cable that you can buy. If you can't get 6mm any for reason, 4mm is fine, but we recommend 6. It should be black because for electrical purposes it isn't actually an earth cable, so you shouldn't be using a green and yellow. It should be a black to indicate that it's a low voltage earth reference or 0 volt reference. Okay, it then goes on to show you there a main controller with power supply to each panel. For our system, we describe a panel as being a front entrance panel. I know some installers think of a panel as being a swirl cabinet. It tells you there what you need out to there. It's important to note at this stage that we list the RFID access controller cable separately. The reason for that is that we are able to use many different systems, many different fob systems with the Apex, so we do put that separate. Okay, you've then got lock relay to locks. So where we supply our lock voltage from the inside, the safe side of the system, you always take the lock voltage from the intake cupboard. It doesn't come from the entrance panel, and it shouldn't join in the entrance panel. With the exception of systems that have a fire switch on the outside of the building, the lock wire should never go to the unsafe side of the door. It should always be on the safe side of the door. It tells you require a 1.5mm pair to do the lock power. Okay, we've then got the lock relay to exit switch, lock relay to fire switch, which we'll go over in a moment. Main controller to camera. So it tells you there it's got to be an RG59 coax cable, 75 ohm. Please do use RG59 coax. We have previously seen companies use similar cables and they do not work. It is possible to use twisted pair with a ballon. I would just remind you to make sure that the ballons are a pair. They come as pairs and they need to be used as pairs. Lastly, you should have a 2.5mm twin and earth for your incoming cables, your incoming mains, and a 6mm earth cable for your circuit protective circuit conductor. Okay, it does just give you a little test there for pure copper. Another test which is sometimes easier to do. It's a little bit basic, but if you hold a lighter underneath the cable, if there is any issue with the copper, you will actually see it boil off, and at that point you know that it's got an issue with it. Okay, so on page 5 of the document we have a very basic system layout. So it shows you here a lock mechanism, a fireman's override switch, a push to exit button, and then back to the equipment cupboard. It shows you there the cables going out to the door entry panel, and then the amount of cables going out to your handsets. Just note at this point we don't show options for a dome camera. If you did have a dome, then you have to run a 12 volt and a coax cable for that as well. So it's an RG59 coax. Okay, so we'll just scroll down that one very quickly. The manual then goes on to show you the back of the entrance panel. It is worth seeing here because the back of all the entrance panels is the same. On the part here on the display board you've got speaker, tone and mic. They do exactly that. One lets you adjust the speaker volume, one lets you adjust the microphone volume, and one allows you to adjust the tone that is generated as a reassurance tone. It is worth setting those as you go round. You can imagine if this is outside somebody's window, you don't want the reassurance tone too loud, so you want to turn that down. Okay, this is how your equipment will actually work. This is on page 7 now. So it shows you there the Apex main card. We then have the 2 lots of flat marshalling card. And in this example, we have a single one door TRM relay. So that is where your lock voltage would come from. Where you are buying your access control systems from us as well, usually in here we would actually pre-bolt the access controller. And then where possible, we would pre-wire it to our system. I'll just scroll through that one. Just to double check, and I do appreciate I said it earlier, that is where that pre-made link is. Okay, so that there is your incoming mains. You're earthing the chassis plate with the incoming main signal, and then you're linking the DC 0 volt to that point. So you only do that at one reference point, usually the ground floor. Okay, page 8 goes on to show you that again, and it documents how we set the set the power supply up. So it is worth, once your system's fully installed, all the locks are connected and so on, that you just double check the voltage that's coming out of your power supply. There are two types of power supply that we do with the system. We do a 60 watt and 160 watt. The 60 watt relates to around about 5.5 amps. The 160 watt relates to around about 11.5 amps. As a basic rule of thumb, where you have two doors on the system, we will have a 60 watt. Above that, we would have a 160 watt. It is possible in certain environments to use more than one power supply if we are to put all the equipment in one cabinet. But the manual here just takes you through just how to adjust these settings. So yeah, once you've got the system on, fully operational with all your flats, all your doors connected, all your cameras, everything else, you just double check that you've got 13.8 volts coming out at the ground floor, and then you should be okay. The system then takes you through onto page 10. It documents the entrance call panel connections. So this is from your door bus. Okay, so with the system you've got a vertical bus and a door bus. On your Apex main card, as you look at things at the bottom right hand corner, that will talk down to either your Apex entrance panel where you've only got one door, or where you've got more than one door, it will talk down to the TRM4 relay. Okay, so where you have a TRM4 relay, it will talk out on a ribbon cable. Where you have the Apex entrance panel, you join your cables there. So your A and B data, your S1, S2, and your in. In connection is actually your door release connection on the entrance panel. It's labelled up in because it does have other abilities for this system, but in effect that is actually doing your lock release. Okay. We'll just scroll down there then to page 11. It just documents there how to make the BNC off. It is worth putting a bit of tape over the connections on that. It's just good workmanship, good practice. And what it also does is it stops the shield of the BNC firstly touching any connections on the entrance panel itself, but it also stops it touching anything on the Entratec back box, the entrance panel back box. The reason for that is that back box could potentially be a different earth than the one that you've connected up earlier on. So it is worth just put a little bit of tape around the connector there. Okay, each entrance panel does need to be addressed. The way our addressing works is that you can have 16 addresses related to every Apex deck board. So if you've got an Apex main card, that can have addresses 0 to 15 connected to it. So you then address your entrance panel as 0, 1, 2, 3, 4 and so on. The next Apex card up can have the same address numbers. So you can have 1, 2, 3 and 4 on the second Apex deck, and again on the third and fourth and so on. Okay, it documents there how to set that, but it's binary. So 1 is 1, 2 is 2. To make 3 you use 1 and 2. Okay, this is where I mentioned earlier about your call panel settings and your address settings. It's worth noting that the switch number 6, the very last one there, if you was to push that up, it makes the system unreadable when you look at it using the Apex setup software. So on older systems, previous systems, it can be useful to switch that up to enable you to read the system in. Okay, this is what we call the secure lock relay. So the board itself is actually called a TRM4. Excuse me. It's a timer relay module 4 indicating 4-way. In this environment, it's used as a secure lock relay. It can be used as a lift control relay. Where you have more than one door, you will now have a SLR4. If you only have 2 doors, that means you get 2 spare ports. It's the same across the board. What it does, it gives you a place to connect your door panel on the left hand side there. It gives you a place to connect the push to exit here, and it gives you a place to connect your lock output, and you've also got a volt free contact. That could be used for maybe triggering an automatic door opener. It could be used for making a beacon flash, that kind of information. We have got an emergency dropout relay on there. The purpose of that is that we could have maybe an override switch, which when activated, it could then unlock all the doors that you've wired it into. It's important to note that it shouldn't be used for fire safety. Okay, so where these systems are used in conjunction with fire, the fire alarm company should be supplying relays to break the positive and the negative locks in accordance with BS 7273. Now that's a document that is recommended. It's not necessarily applies to every door. However, the fire alarm company should be advising you on that. The way it would work is that they would supply a relay to unlock the door in the event of fire. It's important to note that those relays should be monitored, and they should also be rated for the current draw of the lock mechanism you've got. So the way the Entratec relay works is that we supply 2 amps per lock channel. So an SLR4, a TRM4, apologies, would give you 2 amps per channel. It has the ability to absorb up to 5 amps, which means if there's any inrush current from the locking mechanism, that's fine. However, it can only supply 2 amps. So where you've got any locking mechanism that pulls more than that, you need to consider fitting its own power supply. The drawing below that shows you there the 1-door version. It's very similar. It's quite obviously a 1-door version of it. There we have it there on page 13. On this one, it's data driven. So you've got 12 volt, 0 volt, B and A, and then you've got a trigger. So you are able to put a trigger into there to trigger that relay to activate. With document here, it's easy to see here how to do the system. So we would usually break the 12 volt through your push to exit button, through a fireman switch if you had one, and to the lock. I'd like to draw your attention at this point to the lock suppression. So the easiest way to think about this, and it's kind of an industry faux pas to relate electronics to water, but the easiest way to think about this is that if you turn off a tap, you always get a last little drip of water. Electricity is exactly the same. When you lock release, there's a tiny little bit of electric left over. It's got nowhere to go. So if we fit a diode across the lock, it allows it to flow into the lock mechanism, and then it gets dissipated. Without the diode, what happens is it can feed back into the relays, and then it kind of gets fur inside the relays. Once that situation happens, the relays then start to stick. One day they'll work, one day they won't. So it's very important that we fit a diode across the relay. The way we do it is the silver line goes to the positive incoming voltage. You need to get that as close to the actual lock mechanism as possible. Many locks nowadays will have diodes already fitted across them. We ask that you fit ours in addition to that. The reason is that the one in the lock is there to ensure that the lock has a smooth opening, so there's no drag. When you do a lock release, the lock releases. It's not there to protect what's powering that lock, so it's very important that we fit our lock diodes across there. There are 2 supplied with every entrance panel. They are very easily to come by, and we can supply them if you lose them. So it's very important that we fit the diode that is supplied across the lock. So often now lock mechanisms will have diodes or smoothing circuits built into the lock. However, that is there to ensure clean and good operation of the lock, so that there's no drag on the lock. It does a lock release and it opens straight away. The diode that we are fitting is there to stop any voltage feeding back into the system. So if that happens, it feeds back into the relay contact, and it can kind of fur up the relay. In extreme situations, it can also cause problems with data. Again, this isn't just Entratec products, this is door entry products across the board. So yeah, we would supply a diode. We use a 1N4007. We supply 2 of those with each entrance panel. It is worth noting that PAC and KMS and some other suppliers, they supply an MOV. When used in this environment, it's doing the same job. It's doing the job of 2 relays back to back. So if you have an MOV, it's better than nothing, but we would ask that you fit a lock, a 1N4007 diode across the locks with the silver line to the positive incoming supply. Okay, so I'll just scroll down now a little bit further. It now takes you onto the easy tag system. It's a very straightforward concept. We bring in 12 volts to the reader, A and B data, and then you address it. Again, it can't be the same address that you've already used on that deck. So if you had an easy tag system, you had an entrance panel with a reader built in, that would usually be addressed 0 or 1 or 2. That address would be the same for the reader and the entrance panel. Setting the one address sets both. If you then had a bin store, a bike store, your reader would then start at number 4, number 5, number 6, and so on. And again, it's binary settings. Okay, where you have a one door lock board, a one door TRM relay, it's possible to adjust the timed output manually using a little pot down by the address switches. It gives you 1 second to 60 seconds, so you can adjust it there. Where you're using the new TRM4, that is set by using the Apex setup software. So you would need a programming lead to do that. We then go on to detail the Apex main board and the expansion board. So the main difference between the main board is that a main board has a door bus. It feeds out to door panels and door panel related things such as a fob reader. The expansion board doesn't. The expansion board only feeds out to flats. Okay, again, they do need to be addressed. So each one has an address setting, it's labelled there as H and F on this diagram. You need to address them the same. They can't be the same number, so you would usually start at 0 at the ground floor, 1, 2, 3 and so on up the riser. Okay, you can't have two deck addresses the same number. And again, it's binary. Okay, we then detail on page 16 how your vertical bus works. So as I mentioned earlier, you've got a door bus which talks to your door and door related things, and then you've got the vertical bus which talks usually up the building, but it could be talking out to the block next door. So this is a cutout picture here showing you the Apex main card, and it shows you the top left hand corner and the bottom left hand corner. Do just note that plug there is a little bit tight, so when you're making the connections there, do unplug it, pull the snap terminal up, make your termination and then snap it back down. Don't try to make the termination with it plugged in because it hits that ribbon cable. So it's just a little niggly thing there. This is your A and B data out. We'll go on to colours later, but it's very, very important that the correct colours is used at this point. So you would go out of this board, up the riser or out the building to your next Apex main card or your next Apex deck, and they would come in at the left hand side if you've got an Apex main card, and on the right hand side if it's a deck. A little niggly thing is that this plug is actually upside down, so A does go to A, B does go to B, but as you look at the plug, the plug will be up the other way, so just keep a little eye on that. Okay, we then look at there's some settings on there for call timers. It's very rare that you need to adjust this, but it is possible to adjust how long the call tone is, how long the handset will ring for, and then how long you've got to speak for once you pick the handset up. We then got the handset marshalling board, as you can see here. So this is where you connect your flats. It's worth noting there again that these boards are built for a production use. They're not built for a site. Each one will come out with a terminator, a 75 ohm terminator relay across the coaxial input. You need to take that off except for the very last one on the system, so you only terminate it at the highest point of the system. If you forget to take it off, you'll have a clear picture, but it will be very, very dark. Sorry, it'll be very, very light. The more that you take off, the darker it will get. So if you've got a dark picture or a light picture, don't go down the routes of adjusting your cameras. The chances are you've got to terminate it differently. Okay, so where you haven't got any termination, it'll be a very, very bright picture, and where the picture's too dark, it will be you've got too many terminators. If you've got a kind of a ghosting image, a fuzzy image, the image isn't locking in, then you haven't got a terminator at all. So putting one on there will achieve your goal. We do have a video in positive and negative there. They're not actually used. It's for possible future use. It isn't possible to bring the video signal into there as yet. If you're using balance for your video transmission, you still do terminate it at the last one. It still works that way. Okay, we will skip the handset connection a little bit because it's quite clear what they do. I'll just point out that the dashed lines indicates that you don't need those connections. So CB in most environments would be concierge. X is a terminal that allows you to have an input into the system if you had a concierge, and possibly an output system if you had like a beacon. On the video handset, it's similar. We rarely use the DS line, the door switch line, which is a monitoring light, and it's possible not to use the BZ because we can put the handset into a self-call mode. Okay, as we look down here now onto page 19, we had the VS4 video switching board. The way this works is that it switches whatever these are addressed as to the output and then up to the flats. Usually entrance panel number 1 would be port number 1, entrance panel 2 port 2, 3 port 3, and so on. When a call is made from entrance panel 1, it puts that signal through to the output, which feeds into your flats. It is possible to put a 0 volt short to any of these ports, which would then put the image direct to your flats for test purposes. We can program this in many different ways. For example, where you have an entrance panel and a dome, we can program 2 of these to be the same number. But in most environments, it would be set as 1, 2, 3, and 4. It then documents how you take the video signal up the riser. Again, we show RG59 coax. It is possible to use balance and twisted pair. Okay, the next page is slightly dated now because a lot of these features are done from the programming, and so you would rarely touch it. However, if you did want to, from the entrance panel you could go into these menus. So what you would do is you would drop the entrance panel forward and press and hold the programming switch for 5 seconds. Okay, where you had an easy tag programming card, you could go straight into the menu. From there, you've got a lot of different options. We won't go too deep into it, but you've got the auto call. So on the handset, if you press a button at call panel and you don't press the call button, after 4 seconds it will start to call. So it's possible to turn that off if it becomes a problem. We never have had to turn it off, it's always worked. You've got an early unlock time. You wouldn't really adjust that because that is now set by your timer relays. You can change the language of the panels. It's very, very rare you need to do so. You've got the voice volume, you've got the mode. Nowadays mode is very, very rarely used. Previous systems, we could have a functional system, a digital system, and a one-way system. But nowadays, they would normally be set as digital, so you don't have to use it. We've got commission on there, so it is possible to change the addresses of the flats from here. So if your Apex card was programmed up and for some reason you wanted to change what port the flat was in, it is possible to change it from here. However, it's a lot simpler to use the Apex programming system. So yes, you can do it from here, but it's a lot easier. You've then got the ability to do coded access from there. And you can set a trades clock from there if you wish. Although the trades clock is being set from there, the trades clock itself is held on the Apex main card, so you're only actually using the entrance panels interface. It then goes on to take you through the voice volume. So where you've got a system with a voice over module, it may be that you want to adjust that because obviously if that's outside somebody's house, it could be quite annoying. Okay, it takes you through there how to go through these things and how to set codes and coded access. Okay, we'll just scroll through that. The time clock there, it explains how to set the time and the different options you've got for time clocks. Okay, and now probably the most important page of the booklet is the color codes. So this is our recommended color code. It is very, very important you use the correct colors for the A and B data. Okay, where it's possible, we'd like you to follow the other colours. You know, we do appreciate there may be a broken core and that kind of thing, but where possible, please do follow these colours. But the A and B data, it is very, very important. So the B would be white or blue, and the A would be blue or white. Okay, what you can't do is you can't put 2 wires for B and 2 wires for A, or maybe the blue for B and the orange for A. It has to be a balanced line of the cable. It would really cause a lot of issues. So if you had to use different colours, use a different pair of colours. For example, white of orange and orange of white. It then takes you through there exactly what the colours should be. Do note that where you have video handsets with a concierge system, if you're using full functionality, you should be using a 6-pair cable. The reason for that is that you would have the door monitoring switch. So without that, what it's possible to do is when you do a lock release, you will get the light indicating the door has been released. However, it will go off as soon as your handset hangs up. The door switch is possible to stay on to indicate the door has been left open. So it's very rare that anybody uses that nowadays, but if you do require full functionality, you should have a 6-pair or 2 Cat5s. Where that's not required, 1 Cat5 or 1 CW1308 4-pair is absolutely fine. And it takes you through what to do there. Again, where you've got a concierge or a double handset or 3 handsets within a flat, you use the BZ wire, the wire that would have been BZ, the orange and white. You would use that for any function you wish. It is important also to note at this stage that any handset will need its own cable. So if you had more than 1 handset in a flat, each handset would need its own cable and its own port on the Apex marshalling card to wire back to. Okay, and that sums up the manual. So that's available at Entratech's website, which is camedownload.net, documents, tech docs, Entratech, Apex installation guide.pdf.